Starship isn't just designed to transport things to orbit and back. It's built to carry humans deep into space, to stay there for long periods, and to make space travel scalable and affordable. Its stainless steel structure, heat shield tiles, and full reusability are all part of a plan to make life beyond Earth possible, starting with the moon. But a moon base requires more than transport. It needs power, shelter, life support, and autonomy. SpaceX is tackling these needs on multiple fronts, not through isolated designs, but through a modular, system-wide vision. The first step is power. A lunar base can't rely on Earth for electricity. The moon has a 2-week day and a 2-week night. That means solar energy is plentiful, but storing it for the long night is a challenge. SpaceX is exploring a combination of solar arrays and battery storage systems, potentially using Tesla's energy division to integrate scalable battery units like power packs or megapacks. Shelter is next. The moon's surface is hostile. Extreme temperature swings, radiation, and micrometeorite impacts. Habitats need to be shielded, insulated, and sustainable. SpaceX is likely to begin with prefabricated modules carried by cargo starships, then gradually transition to structures built using local materials like regolith, possibly through 3D printing technologies already in development by NASA and private companies. Life support is critical. Closed-loop systems will recycle air, water, and waste. These systems must operate with near-perfect efficiency, since resupply from Earth will be rare and expensive. Learning to maintain these systems on the moon is the dress rehearsal for Mars, where no backup exists. Automation ties everything together. Building and maintaining a base will depend on fleets of autonomous machines, rovers for transport, cranes for lifting, drones for inspection, 3D printers for construction. All operated with minimal human oversight, all coordinated by AI systems, possibly connected to Earth via Starlink for remote control in early phases. SpaceX doesn't need to invent all these technologies alone. Instead, it's positioning itself as the backbone, the delivery system for other companies and agencies to plug in their systems. Just like the internet needed routers, not websites, the space economy needs Starship to move people and payloads before anything else can grow. And once it starts, growth becomes exponential. The first few Starship missions might carry nothing more than solar panels, life support modules, and digging equipment. These early landings will prepare the ground literally and figuratively for humans to follow. The robots will clear landing zones, set up solar farms, and prepare storage tanks for harvested ice. By the time astronauts arrive, the essentials, power, air, and shelter, will already be in place. After that, SpaceX can scale. Additional starships can deliver advanced habitats, research labs, greenhouses, and vehicles. Everything is designed to stack, connect, and grow. Starship isn't just a rocket. It's a logistics chain. And the moon base is the first distribution hub for humanity's expansion into space. That hub won't just support science. It will unlock business. Lunar mining, satellite assembly, fuel production, space tourism. These are not distant dreams. They are industries waiting for infrastructure, and SpaceX is building the highways. This shift from exploration to infrastructure marks a turning point in space history. For decades, missions were about reaching places. Now, they're about building them, and the moon is first in line. Getting to the moon is hard, but staying there is harder. Once the first infrastructure is in place, power, shelter, and life support, the real challenge begins. turning a remote outpost into a functional, sustainable base that can support human life not for days, but for months, even years. SpaceX knows this. That's why its plan doesn't stop at landing Starship or unloading cargo. The long-term goal is to create a base that can grow, adapt, and even replicate itself over time. The first expansion comes through habitability. Early modules will be tight and utilitarian, pressurized cylinders with essential systems. But as more missions arrive, the base can be expanded outward with new modules for sleeping, eating, working, and experimenting. These can be docked